right, question 3 part C. Jake has a mass of 75 kilos and is doing a jump. He has 3,200 joules of gravitational potential energy at the top of his flight. Calculate his downwards vertical speed just before he lands, assuming energy is conserved. All right, so he's at the top of his jump here. Now, at the top of his jump, he has complete potential energy, gravitational potential energy, and that potential energy is equal to 3,200 joules. And then as he falls, that energy is converted into kinetic energy. So just before he hits the ground, so just before he lands, he's got sort of all that energy has been converted into kinetic energy because it's kind of like a sliding scale between that. And because we're assuming energy is conserved, we're assuming that that kinetic energy is 3,200 joules as well. So assuming energy doesn't, it always pays to restate this. Energy is conserved. Potential energy at the top will convert into kinetic energy so that just before he lands, kinetic energy will equal 3,200 joules. Okay, so once we know that EK is equal to half mv squared. Now what we're trying to find here is V, so we need to rearrange this equation so that we get V out. So EK, so let's start by going times 2, so to get rid of the half here. So that'll be 2 EK is equal to mv squared. Now let's get rid of m. So now we've got, get rid of that then. So V squared is equal to 2EK over M. And then let's get rid of the squared. So the opposite of a square is a square root. So we have to square root everything on that side. So that means that V is equal to the square root of 2EK over M. Now we can actually write that in. So V is equal to the square root of 2 times 3,200 divided by his mass, which we know is 75 kilos, so 75. All right, so 2 times 3,200 equals, and then divide it by 75 equals, and then let's see if I can square root it. So the square root of that is 9.24. All right, so equals 9.24 meters per second. All right, so the next question says, explain why Jack's actual speed when he lands is slower than that calculated in part 2. So when Jack falls, not all potential energy is converted to kinetic energy. As he falls, he will cause air resistance as the air particles rub together, and this friction will allow for some energy to be lost to sound and heat energy as a result of the energy loss. EK will be lower and therefore velocity will be lower. All right, so you need to really go through that relationship there, that some of it is going to be lost and therefore the kinetic energy is going to be less and so velocity is going to be less. Now those two together are an excellent answer. There's definitely marks there for merits. sort of